Here is just a kind of a recap of some functions we've talked about already. So, you know, the linear function, you spent a lot of time with that in Algebra 1. That's your line y equals x, or f of x equals x. And then we focused on the absolute value function last semester. I believe it was Unit 4, if I'm remembering correctly. And then quadratic, okay, our y equals x squared function that graphs the parabola, we focused on that one the last 2 units. So Unit 6 and Unit 7 were all about the quadratic function. Okay, so what we're going to be looking at today is the square root function. We're moving on to our next function. Okay, so we're going to start off by getting all of the information about the parent function. Okay, because we need to be able to graph these square root functions. We need to be able to give the key attributes of the function. So things like domain and range, intercepts, the vertex, and describing transformations. So if you don't recall what a function looks like, if you don't just remember it, you can always make yourself a table of values. So for instance, here I have the table set up. If I don't know where to start this graph, I can just pick a point and start. Okay, so I'm going to pick x as my first input, or excuse me, 0 as my first x, which is my input. So if I come to the equation and I input a 0, what is the square root of 0? 0. So that means when I input a 0, I get an output of 0. There's a point at 0, 0. So I can plot that on my graph. Okay, what if I input a 1? What would be the square root of 1? 1. So there's a point at 1, 1. I don't know why it keeps giving these random extra lines. All right, now I could input a 2, but is square root of 2 one that I know off the top of my head? The square root of 2? What number multiplies by itself to give us 2? Does anybody know that? I don't know that. It's a decimal value. 2 is not a perfect square. Okay, so I'm not going to use 2. I'm going to think about what my next perfect square would be. After 1, what's the next integer that I know the square root of? That gives me an output of an integer, not a decimal. Yeah, it's a 4. Or you can think backward. If we want our output, our y, to be an integer, you can think backward and say, what am I going to take the square root of to get 2? And the answer is 4. The square root of 4, if I input a 4, the square root of 4 is 2. Okay, so there's going to be a point at 4, 2. Okay, so you can continue to think backward if you need to, or if you know the next perfect square, what is that? What am I going to take the square root of to get a 3? What is 3 squared? 9. So notice thinking backward, instead of figuring out what the input was, I knew what I wanted the output to be, and I knew the opposite of square rooting is squaring. So this table, do you see how it's like inverted from the quadratic, from the x squared table that we did last unit? Okay, it's like the x and y's just flipped. Do y'all see that? Okay, so let's plot that point at 9, 3. All right, so this is my parent function. Now, the reason I drew an arrow to the right is because I could continue inputting larger and larger x values, couldn't I? And keep taking the square roots of them, and they're going to keep getting bigger. So as this goes to the right, it's going to keep going up slightly. Do y'all agree? So I drew an arrow to indicate that. But here on the left, I did not extend past this 0 and draw an arrow coming down. Why do y'all think that is? If I went to the left of this 0, x is 0, what x values are to the left of 0? Negatives. Can I take the square root of a negative? No, that's when we get into those imaginary numbers, and those don't show up on our graph. The graph does not extend past this point, okay? This endpoint, we're going to call it our vertex, okay? The graph does not go left of that because your input cannot be negative for the square root parent function. If you want to make a note of that somewhere, why it stops there, why it doesn't go on, you can make a note of that, okay? But we're going to stop there. Now, nobody has asked it yet, but I anticipate some people are thinking it or will ask it later, so I'm just going to go ahead and address it. Some people, every year when we talk about square root functions, they want to know, why aren't we putting a plus or minus in front of the square root? Because when we were just solving square root functions, when you take the square root, you always put a plus or minus in front. And that's the difference. We were solving. We were taking the square root as a step in solving. So we have to put the positive or negative possibility. Here, we're not putting that square root. It's already there. The function is given to us as the square root of x. So it is understood to just be positive. Okay, I didn't put that square root there as a step in solving. It was already there, and it shows there's no sign in front, so it's an understood positive square root of x. So this is the graph of the positive square root of x. If we were to put a negative in front of it, what do you think that might do to the graph? If we were to say the negative square root of x. Does anybody know at this point? We'll come back to it later if nobody remembers at this point what a negative in front would do. That's okay. All right, so back to this parent function. What is the domain here? Remember, your domain is your x values. Okay, so how far left to right does this graph go? What is the furthest left point? Yeah, right here. Right here is the furthest left that it goes, and the x value there is 0. What is the furthest right that this graph goes? Infinity. Okay, it's an arrow to the right. It goes forever. So in interval notation, we would say 0 to infinity. And is the 0 included? So we use a bracket to indicate that it is included. Okay, infinity is never included. We always use a parenthesis with infinity because you can never reach it. How would I write that domain in inequality notation? That's interval notation that I have written. Inequality uses greater than or less than symbols. What's one way that I could write that as an inequality? Okay, so put the x in between the, so I think what you're trying to say is have the 0 and then the x and then the infinity, and we're going to have some inequalities in between, but let's think about what those inequalities should be. Okay, the 0 is less than the x, right? Because x is only going to be greater than 0. Do you agree? So the inequality should be opening to the x, and it can include the 0. Okay, but the x is never going to be reach infinity, so we're not going to have the or equal here, and x is going to have to be less than infinity. So x is greater than or equal to 0, but less than infinity. So x is somewhere between 0 and infinity, and it can include the 0. There's one other way to write that. Instead of having to write, when you have an inequality notation, and there's an infinity or a negative infinity on one end, you can actually write this a little more concisely with just one inequality symbol. You don't have to include the infinity because it's understood. So I could just write this with the x and the 0, but when I do that, we usually write the x first. So we would write it as x is greater than or equal to 0. So x is everything bigger than 0 or equal to 0. It's understood that that goes to infinity. So all three of those are correct ways to write that domain. What about the range? Range is your y values. So again, x was left to right because it's least to greatest. So range, least to greatest, would be bottom to top, the lowest to the highest point. So what is the lowest that this graph goes? 0. And what's the highest? Infinity. As it's going to the right, it's going up. So it's also going to infinity. So the range is the same as the domain. In interval notation, they look identical. What's going to change in inequality notation? Yeah, it will be y's instead of x's. So you could write it like this, saying y is between 0 and infinity and includes the 0, or just y is greater than or equal to 0. Those would all be correct ways to write your range. Now I can tell you right now, there will not be more than one intercept, x-intercept or y-intercept. Okay, I know it's plural here, there's s's, but a function never has more than one y-intercept because to be a function, every input has only one output, so you cannot have more than one y-intercept. It would fail the vertical line test. And then x-intercepts, sometimes there are more than one x-intercept in functions, but not in a square root function. If you think back to quadratics up here, the quadratic, that U shape, or the absolute value, the V shape, if I shifted those down, those would cross the x-axis twice, wouldn't they? So they can have more than one x-intercept. But could the line? Would a line ever have more than one x-intercept? No, because it never changes direction, right? These two change direction. So that's why they could cross the x-axis twice. The square root function never changes direction, does it? So it could never cross the x-axis more than once. So for a square root function, there will always only be one x-intercept. So you can mark those s's out. There will never be plural for a square root function. There will only be one x-intercept and one y-intercept at most. It could never cross, okay, but it will never have more than one. All right, in this case, in the parent function, what is the x-intercept? Where does this graph cross the x-axis or touch the x-axis? At 0. 0, 0 is the point, okay, the origin. What about the y-intercept? Where does the graph cross the y-axis? Also at 0, 0. If you put the origin 0, 0 as an x or a y-intercept, you better be putting it down for both because that is on both axes. If you're at the origin, you're on both the x and the y-axis. All right, so the parent function starts at the origin, has this vertex at the origin, okay, this endpoint or starting point, whichever way you want to think of it, okay, and then it shoots out up and to the right, okay? So that is our parent function. So now nobody, a second ago when I asked, what if we put the negative in front? Nobody could answer what would happen to the graph. So we need to review our transformation rules, which is what's next here on our notes. Okay, our transformation rules do not change when we change functions. So these are the exact same transformation rules that we just used in quadratics, that we used last semester on absolute value functions. A, H, and K always have the same effect on the graph. It doesn't matter if it's absolute value or quadratic or square root or others that we'll get into later. The function type doesn't matter. The transformation rules are always the same. Okay, remember A and K are outside the function. Okay, to jog your memory, when I say outside the function, I'm just going to write this in terms of f of x. H is inside being subtracted, K is outside being added, and A is outside being multiplied. It doesn't matter what the type of function is. So back when we did absolute value, it looked like this. There was absolute value bars. A and K are outside, H is inside. When we did quadratics, this is what it looked like. X minus H was in parentheses squared, because that's what a quadratic is X squared. Now, this is what it looks like for square root. So instead of the absolute value symbols or the parentheses squared, it's a square root symbol. Y'all see the difference? That's the only difference. Where the A and the X minus H and the K are, that doesn't change. If you want to go ahead and write it here all lined up. So this is the same setup. Y'all see that? How it's always the same. The only thing that's changing is when you change the type of function, A, H, and K do not change. It's just what is separating the inside and outside of your function changes. Does that make sense? Y'all see that? Okay, so A, when we were just doing quadratics, what did A do to the graph when it was negative? If this was a negative A, what happened to our parabola? Do y'all remember? It flipped over the x-axis, upside down. The same thing is going to happen to the square root. The same thing happened to absolute value, and the same thing is going to happen to square root. When that A value is negative, it's going to flip upside down. Okay, so A here affects our orientation and shape. Okay, right here, this first bullet point is talking about when A is less than 0. Less than 0 means negative. If you need to write negative A next to that so you know what that means. When A is negative, when it is less than 0, your graph is reflected across the x-axis. Okay? So if you want to see a visual of that, remember the parent function goes like this. If you were reflected across the x-axis, it would go, oh, come on, don't get me extra spots, like this. It would be upside down. That's what it does to the graph. It reflects it over the x-axis. Now, if the number value of A changes, and I say changes, what is it in the parent function? What is your A up here? Is there anything in front of that square root function? So what's it understood to be? It's an understood 1 in the parent function. Okay, so if A is something other than 1, if it is greater than 1, your graph is stretched vertically. If it is less than 1, your graph is compressed vertically. And those are the same rules as it was just with quadratics last unit. We said vertical stretch and vertical compression based on the value of A, right? Y'all remember that? And we said, imagine putting your hands on top and bottom of your graph, and vertically stretching is pulling them apart so it looks taller. Okay, And vertically compressing is squishing your hands together so it looks shorter, wider. Okay, so that same effects on the graph as we just talked about last unit with quadratics. So that's how A affects your graph. If it's negative, it's going to reflect over the X. And if it's not a 1, it's going to vertically stretch or compress. Okay, now the H and K are your translations. You're shifting. Okay, H is horizontal. Okay, so that's left and right. So that H value in there is going to tell you your horizontal translation, how far left to right that you go. Okay, just put a, if you forget what horizontal means. Okay, now it's always X minus H in the equation. Notice all of these say X minus H. Okay, so remember, when you plug in a positive H, that's not going to change that. It's going to stay a minus. So when you see a minus in the equation, the H is actually positive. So when your H is positive, it's going to show up like this. X minus H. That's actually a positive H. And that means your graph is shifting to the right. Now, if your H was negative, what happens if I plug in a negative and I have minus a negative? What does it become? Becomes plus. It becomes plus positive. So it would actually look like this. X plus H. That actually means that your H is negative and your graph is shifting to the left. Okay, and where that H shifts, left or right, that is going to shift your domain as well. Your domain is going to shift with the H. Because in that parent function, that x-intercept, y-intercept, that's your vertex at this point. That's your HK. I'm going to make a note of that up here. My H in the parent function is an understood 0. My K in the parent function, remember K is what's added on the outside, is also an understood 0 because there's nothing added or subtracted inside or outside in the parent function. So you remember that your vertex, that like starting point there, is always HK. So it's 0, 0 in the parent function. But when we transform our graph, if we have something other than 0 for H and K, it's going to affect our domain and our range because our endpoint, our vertex there is shifting around. Okay. So K is the vertical translation. So it's shifting our graph up or down. And it's plus K in the equation. So it's K units up. If you see outside the square root, outside of that, you see a plus some number, plus K. That's going to shift your graph up. But if outside your square root, outside your radical, you have a minus number, minus K, that's going to shift your graph down. Is that coming back to y'all? Horizontal shift is based on H, vertical shift based on K, reflection over the X, and vertical stretch or compression based on A. You ready to try some? All right, flip it over. Let's look at this first example. They want us to graph the parent function, the new function, state the domain and range, and the transformation. Okay, so the first thing I'm going to do is put the parent function on there. So I'm going to use 2 colors, or I'm going to actually use a few colors. But you can, if you only have a pencil, you can do the parent function real light, and then the new function darker. Okay, I just got this parent function from what we just talked about on the front. Okay, so that's my starting point. And now looking at my equation, I think it's a good idea to identify A, H, and K. I'm going to actually put the equation back here at the top. Okay, so we can refer to that. So in example 1 here, what is A? Is there anything in front of that square root being multiplied? No, so it's an understood 1 coefficient. Okay. What about H? Is there something inside with the X? Yeah, it's a -1. So H is what? Is H 1 or -1? Dan? 1. It's the opposite sign that you see in there. So H is actually a +1. Okay, and then your K, is there anything added or subtracted on the outside? Not under the radical, is there anything? No. So K is a 0. There's nothing added on the outside, so K is 0. So I've identified my A, H, and K, which is going to help me describe my transformation, and it's going to help me plot my vertex. Okay, so A, no transformation based on A. It's the same as it is in the parent function, just a +1. But H is my horizontal shift. Since H is 1, this is a shift right 1. And then since K is 0, that means there is no vertical shift. So my only transformation here is right 1. So since we have the parent function here, we can go to graph this and we can say, well, I'm just going to shift all of those points right 1. So when I go to graph this, there's the new function. It just barely shifted. It just went to the right 1 unit. Another option, once I identified H and K, I know that that's my vertex is at 1, 0. That point's at 1, 0, isn't it? That first point I plotted? Right here, y'all agree? I went to 1, 0. And then there was no stretch or compression or reflection. So from that point, you could measure over to the other points from there. You could say, well, the square root of 1 is 1. Okay, the square root of 4 is 2. I went over 4 up 2, or over 9 up 3. So you can do it by shifting from the parent function. You can do it from identifying the vertex and then applying the stretch or compression if there is one. Okay, or another option for graphing these points is to make a table, just like we did with the parent function. If it makes more sense to you to create a table, I would always start with that vertex, which is 1, 0. If I input a 1, 1 minus 1 is 0, the square root of 0 is 0. Okay, and then I would go from there. Be like, okay, what if I plug in a 2? 2 minus 1 is 1. and the square root of 1 is 1. So then there's a point at 2, 1. You can see it there. And then you can keep plugging in. Now I know if I plugged in a 3, 3 minus 1 is 2, that's going to give me a decimal. So you can just kind of play around and pick numbers that are not going to give you a decimal. So if I plugged in, I can see if I wanted a 4 under there, I would need to plug in a 5. 5 minus 1 would be 4, and the square root of 4 is 2. So if I plug in a 5, I get an output of 2. 1, 2, 3, 4, 5, 2. Yep, and there's that point there. You can see all these points from the table are here. Okay, so a couple of different options on how to come up with your graph if you need that. Okay, now domain and range. How far left to right does this graph go? What's the furthest? The green function, the new one. Don't look at the parent function. Look at this new one. How far left does it go? What's the leftmost x value? 1. And then it goes right forever, so to infinity. So 1 to infinity. So notice that was my h value. My domain was affected by my h. Because my graph was shifted left or right, my domain is going to shift left or right. What about the range? What is the lowest value of this graph in the green graph? The y value here, the lowest? What is the y value here? 0. And it goes up forever. So the range didn't change from the parent function. It's the same because notice the k was 0. So the range was not changed. The domain changed because h, but the range didn't change. All good with that? If you were asked for the x-intercept, it's at 1, 0. Does this graph have a y-intercept? No. This new graph does not cross the y-axis. So there is no y. There's an x-intercept at 1, 0, but there's no y-intercept. I know this example didn't ask for that, but you need to be able to answer questions about the key features like that. Good? All right, let's try this next one. Okay, I'm going to put the parent function on here first. So again, that starts at 0, 0, goes through 1, 1, 4, 2, and 9, 3. Now I'm going to identify A, H, and K in my equation so I can figure out my transformations. So what is A here? There's something multiplied in front of the square root. It's an understood 1. All right, so that tells me no reflection because it's still positive and no stretch or compression. Okay, so no transformation based on A. What is H? 0. There is nothing added or subtracted inside the function, meaning under the square root with x. So H is 0. So that means it's not shifted left or right any. And then my K, what is K? K is the positive 5. Okay, so what does that mean? What transformation does take place? Up 5. So the only transformation here is up 5. So I could go and graph that from the parent function. I could say I'm going to take all these points and go up 5. And there's my new function. So what's the domain there? How far left to right does that new graph go? It's still 0 to infinity. Left to right, it had no transformation left to right. So the domain didn't change, and because it didn't reflect or anything either. So domain is still 0 to infinity. What about the range? What's the lowest y value now? 5. It shifted up 5. So the new low point is 5. So my range did change. You feel okay about that? Does this one have an x-intercept? This new graph? There's no x-intercept, is there? But there is a y-intercept. Oh, I didn't write that. I'm going to put that over here. My HK, my vertex, is at 0, 5. Because of HK, I know there's a point at 0, 5. That's the vertex. So it's a y-intercept. This one does not have an x-intercept. All right, I'm going to give you all a chance to try number 3 on your own. I'm going to give you a hint. This one has 2 transformations taking place. Okay, if you're watching this as a video, just pause real quick and give that one a shot, and then we will check it. Okay, those of you in class, I froze the screen. You go ahead and try number 3. I would start by identifying A, H, and K and describing your transformation so you can graph it and then give the domain and range once you have the graph. While y'all are doing that, I'm going to get attendance. All right. I've gone ahead and put the parent function on there to start. Any volunteers want to tell me what A, H, and K are? I can do our random number generator for seats if nobody wants to share. No? Okay, let me pick a seat. All right, anybody in seat 18? I think that's closest to you, Isaac. What is A there? Isaac, what is A? Remember, a is what's multiplied in front of the radical, in front of the square root symbol. What is a in that equation, in this function? Remember, as a reminder, here's what it looks like. A is what's in front being multiplied in front of the square root. So in this example, what is your a? What type of one though? Because there's a negative there. Good. So it's going to be it's understood 1 because you don't see a number there, but it is negative. Good. Okay, what about h? Well, it's x minus h. Remember, here's the equation we're looking at. X minus h under the square root. So what's under that square root being subtracted from x? There's a 2 being added, so what's actually being subtracted? A negative, right? It would have to be minus -2 to come out as plus. Because remember, it's always the opposite sign that you see there. So it's going to be -2 is your h. Okay, and then your k. Well, the k is what's outside, and there's nothing added outside, so k is an understood 0, which means for my point that I'm going to plot, that hk, there's going to be a point at -2, 0. So if you want to go ahead and plot that point at -2, 0, you can. Okay, but let's see what's happening to the rest of this. Because based on our transformation rules, a being negative does what to the graph? Anybody else? I'll pick another number. What does a negative do? It flips it over the x-axis. So this is a reflection over the x-axis. Okay, and then what is that h being -2? That's left 2. And then the k being 0 means it doesn't go up or down any. So it's reflected over the x-axis and shifted left 2. So I can see that vertex has been shifted left 2 from that original origin point. But it's on the x-axis, so there's no reflection over it. It's on it. But this next point, I can see if I go left 2, and I need to reflect over the x-axis, I'm going to be below the x-axis now. Same thing with this next point. I'm going to go left 2, but then I'm going to be reflected under the x-axis. Same thing with this point. I'm going to go left 2, but I'm going to be reflected across the x-axis. And so then wasn't going to hit all those points there. So then I can sketch that curve. So you can see it's been flipped upside down, it's shifted left and reflected over the x-axis. So what does that mean for my domain? How far left to right does this graph go? What's the furthest most x value left? -2. So it shifted left 2. So my domain was shifted left 2. Okay, what about the range? Here's where it has a bigger change. It's not shifted, okay? It's still at 0, but instead of going from 0 up to positive infinity, our graph is going down as it goes to the right, isn't it? So remember, you always go low to high, least to greatest. So instead of 0 to infinity, this one is flipped. It's -infinity to 0. And we still include the 0, but you always have to go left to right, least to greatest. Y'all have a good one. There is some practice in ALEKS you can start on. It's not due till Monday, but you can get started on it.